All right, so let's talk about how we would use this. So let's take a look at this triangle. We see from the picture that it has two congruent angles. This means that it's an isosceles triangle. So that means it's an isosceles triangle. And we know that those angles are congruent. What do we know that we just learned about the base angles? I know that this is upside down, but those are still our base angles. So we're talking an isosceles triangle. It means that the sides across for them are equal. That means x equals 7. All right, here, what do we know? What kind of triangle is this? It gave us these markings telling us that all these angles are congruent. That's what those little swoopies mean. So this is equiangular. Equiangular. And what do we know about a triangle that's equiangular? We know that it's equilateral. If something's equiangular, then we know it's equilateral. Equilateral means all the same side lengths. So if this is 10, that means this is 10, and this is 10, which means what does x equal? X equals 10. All right, last one, a little bit of algebra. So once again, we're given that these two angles equal each other. That's what those little swoopies mean. So if we have two angles that equal each other in a triangle, what does that mean about the sides opposite them? It means the sides opposite them are also equal to each other. So this is an isosceles triangle. We know that they have the same base angles, which means that the sides across them are equal. So that means x plus 19 equals 8. What does that mean x equals? Well, I'm going to take away 19 from both sides. That means that x equals negative 11. Right? 8 minus 19. It's okay to have a negative x. What's not okay is to have a negative side length. So if we plug in negative 11 over here, that means our side length is still positive, but it's okay to have a negative x.